Hey everyone, today's video is going to be on water cooling. I'm not going to go into the basics of what a fitting is and what a reservoir is because that information is out there already for everyone. What I'm going to go over is why you may be doing it wrong. And I see a lot of people online and they're doing it wrong because they're not understanding the point of water cooling. And this is pretty much due to a lack of education from sources online. There are good information written on write-ups on forums from people, but these days people don't like to read, and that's kind of a fact. So I have a video here. We're going to start with looking at the EKWB website. They're a well-known water cooling company and probably the largest one that people are aware of. So starting at their site, the common question people ask is, should I get a kit? Now, that is probably the laziest way to start your water cooling loop. And I would not recommend anybody do that. And I'm going to go over why. Looking at the kits here, I'm just going to pick this right here, okay? So this is the most expensive kit, it seems. And what we get in this kit is a water block, a radiator, some fans, a pump, a reservoir, and some tubing. And some coolant, and a splitter for our fans, and a PWM cable extender for the pump, and a bridge plug to dry test. Now, what this kit doesn't give you are the other parts that you need in your loop, like a drain valve. When you fill your computer with water, and you need to remove that water, you need a nice and clean, effective way of doing so. You can't just unplug one of the hoses and hopefully the water comes out in the correct direction, or you got enough paper towels there, etc. That's not a way to remove water from your computer. And the other most important aspect that's missing here is a temp sensor. When we're water cooling, the most important temperature is not your graphics card, it's not your block, it's not your CPU. It's not the temperature that's most important is the temperature of the water. That's why you need a temp sensor. So when you see questions like, oh, am I getting good GPU temps on water? Am I getting good CPU temps on water? Part of that is missing a very important understanding, which is we are water cooling the water. That is what we're looking at. So that is not in here. So this kit right here is a complete fail, in my opinion. So let's move on to, for example, the next step that people tend to go is the configurator, right? So we're going to jump into the custom configurator here, and you can put in your case. I already did a quick put together with a Liani Dynamic and a Z390 board, and 2080, and let's see what it gave us. Okay. So it gave us, once again, 3 fans, a radiator, and combo res, a monoblock, and some tubing, and some fittings, coolant. If you notice, this is pretty much what we get here. The only difference is that here it picked the blocks specific to our motherboard, right? So let me take a moment to talk about monoblocks. When you buy a monoblock, you have to understand that a monoblock pretty much most of the time will not cool as well as a CPU block. Reason being is it's doing 2 things, right? Just like anything else in life. Any tool that has a dedicated purpose will be better at that particular dedicated purpose than having a tool that does 2 things and doing both, right? It's never going to do both equally well as a dedicated tool. Same goes for water cooling. So ideally, if you want to water cool your VRMs, you're going to want to get a VRM block if they make one, and a CPU block separately. Now let's get into, do you actually need a monoblock? Right. So ever since the X299 fiasco, when X299 launched and the chips ran hot and the VRMs ran hot, most of the boards these days have overbuilt VRMs, right? So this has come to the point where it's purely aesthetic. You do not need a monoblock. Your VRMs are not going, unless you're heavy overclocker on, for example, chilled water or something. You do not need a monoblock. Unless you have a 64 core Threadripper that you run 100% load on all the time, you do not need a monoblock. So when they try to sell, so if you're trying to get into water cooling, I'm gonna come back here, and you know, the cost is a big portion of water cooling. So water cooling is not a cheap endeavor. And one thing is that while you should have a budget in mind, you shouldn't go in there thinking, what can I get for $400? Because that's not a realistic budget, okay? A realistic budget is like 600, 800, 1,000, right? So that is a realistic budget to do a loop that you see like online. Okay, so the first thing we're gonna look at is the drain valve. This is a drain valve. This one's made by Bits Power. Sometimes they'll be designed slightly differently, where the mechanism to operate the valve may slightly differ. Some of them have kind of pull back kind of ratcheting action, but this is what you need in your loop to drain the water out of your PC. These will usually come with 2 female ends. You're going to need something like this, a male-to-male adapter. You're going to twist it on, and at this point you can attach it to your radiator, right? So if your radiator only has 2 ports, like most radiators do, you're going to have to find another way to add this on. This can go into your reservoir, but some reservoir combos only have 2 ports. So you'll need another fitting. This fitting now is called a T-fitting. Oops. So it's called a T-fitting because it looks like a T, right? You have a here, here, and here. Now there's also something called a Q-fitting, which is like 4 ports. There's 6-port variants, but you get the idea. And then you're going to take something like this, and you're going to attach it here, like so. And then now you can attach this port to a reservoir, right? And then you still have a port open for the reservoir that pretty much passes through. And that's how you add a drain valve. Now, why you will need more than one of these most likely, or for example a 4-port version, is for the other item we were talking about, which is the temp sensor. This is extremely important to have in your loop. If you do not have one of these in your loop, I would suggest you add one ASAP. This is how you know if your loop is underperforming or performing well. What this does is it goes into something like a fitting, right? Like this fitting right here. I can put it right here. Or it goes, you can attach it to a reservoir if you have extra ports. You can even attach it to your GPU block, which normally has 4 ports on the terminal. And the other end goes into what you commonly see on a motherboard as T-sensor 1, T-sensor 2. Another important item is the leak tester. Most kits, or you can buy one, even most power supplies these days, will come with an override, so you can power your PSU without having it connected to your motherboard. But this is something you definitely need. This saves a lot of time and a lot of headache. This is an what is this, Aqua Computer? Yeah, this is an Aqua Computer one, Dr. Drop, and this is the EK variant. The concept is the same. You pump air to a set pressure. If you can see here, it goes up to 0.6 bar. I would never go past 0.5 for a full loop. Ideally, you can just test at 0.4 and you'll be okay. When it comes to these 2 versions, this is a couple years old now. I would definitely buy the EK one over this one, simply because this is a plastic thread and it falls apart pretty quickly. So I've had this one for a couple years now. And what these allow you to do is you're testing with air, right? So if your loop is leaking, it will just start dropping on the meter fairly quickly. Within 15 minutes, if you have a bad leak, within 1 minute, couple seconds, it will go down to 0. If you have a small leak, it will start to creep, right? So while the websites tend to say 15 minutes is enough, I think 15 minutes is a little bit short. I would do half an hour. That's probably a better bet. And if you do have a leak, what you can do is put some soapy water near, fittings and so forth, and where you see bubbles is where your leak is. You can also do this is leak test every component before you put it in your loop. The reason I say this is because sometimes it can be extremely difficult to dismantle your loop, right? So let's say you had a leaky radiator and you didn't test it before you installed it. And then next thing you know, you have this leak and you find out it's the radiator. Now you have to take the radiator out. You've just added a lot of time you could have saved if you just leak tested when you first got it. So use a leak tester, air-powered leak tester, and test every component you get. The fittings is, that's a final thing, right? As part of the whole loop. But test your water blocks. Sometimes out of the factory they forget an O-ring. This is very important in terms of keeping your PC safe from leaks. And we're going to go over these 5 things real quick. Number 1, water cooling runs cooler. Technically, your components run cooler because water cooling is more efficient at removing heat from your computer and dumping it into your room. That's why normally with water cooling, your room temperature is going to rise faster than you would on air. But it doesn't mean there's less heat being removed. Okay? Number 2, what is ambient? Ambient is your in terms of water cooling, is your surrounding environmental temperature. So if I'm sitting in a 30-degree room, my water temperature is not going to be below 30 degrees. Unless it's chilled water, or I'm using, like a chiller or something, or ice tub. The water temperature is always going to be higher than ambient. If it's in a 30-degree room, your water temperature might be 32 degrees. Actually, it's about 30 degrees in my room right here, and I can show you my water temperature is 32 degrees Celsius. Right? So then we come down to delta over ambient. This is what they mean by delta over ambient, is what is the difference between the temperature of your water over the ambient temperature, right? So just now, I know it's 30 degrees in here. My delta is 2 degrees. 1 to 5 is ideal, okay? 5 to 10 is good. 10 to 15 needs improvement. 20 is you have a problem, okay? So this is how you can tell if your temperatures are too high, right? So if you're sitting there and you're wondering if your loop is performing poorly and your water temperature is 50 degrees, but your room's only 24, then you have a problem. This is why I say a temp sensor is extremely important. And from there, you can troubleshoot. Maybe you have the in and out reversed. Maybe your pump died. If your pump died, your water temperature is going to go up real quick. Maybe your fans died, and that will slowly build up temperature in your loop. So you get the idea. Now, water block delta. This is very important when you're buying a water block, right? So most water blocks, depending on let's just use GPUs as a comparison. A crappy water block is going to be in the lines of 15 to 20 degrees over water temperature, right? So if your car GPU is running at 50 and your water temperature is 20, that's not so great, right? So the same thing goes for CPU blocks. Obviously CPUs run hotter, but it's hard to you can, by comparing the different water block deltas across water blocks, you have an idea of which block performs better, right? So last gen on the 20 series, I'm not going to name names, I had one block where the delta to water temperature under load was 20 degrees. And if I dropped the water temperature using a chiller, that delta got even wider, okay, which is normal, but 20 degrees is not a good start. Meanwhile, another manufacturer with the water block for the same GPU, I had a 10 degree delta on load, right? So obviously one block is better designed than another. So let's move to number 5. Radiator count. So the ideal rule before was that for every component, 120 millimeter worth of rad space. That makes sense for some things it doesn't make sense. What you should be paying attention to is how many watts of heat your components output, right? So let's just take a 3080, right? So if I have a 3080 Strix and I overclock it and I pull max, I'm pulling 400 plus watts. That means it's dumping 400 plus watts of heat. Is 120 millimeter rad going to be able to handle 400 watts of heat? Probably not. I probably need a 240 at minimum. So this is why the amount of wattage in terms of heat that your components dump is very important when it comes to radiator count. So that 120 per device rule kind of works, kind of doesn't. Radiator thickness. Now, thick is not always better, right? So there's a kind of counterbalance. When you're using a thick radiator, you tend to need to use push-pull to achieve the same results as if you were using just push or pull on a slim rad. Slim rads have gotten a lot better these days, especially like the hardware GTS line compared to back then. So I personally don't see any use in using thick rads unless it fills the aesthetic purpose. Like the case looks empty on top without a thicker rad. But I don't think anybody should be buying those 60 millimeter, 80 millimeter monster rads anymore. That is just completely unnecessary. And here's the thing. People go, if I have a thicker radiator, I can run push-pull and run my fan slower. Okay, that's true. If I have a slim rad, I have to run my one pull or push fans faster. That's also true. By the same time, 8 fans is going to be more noisy than 4 fans. Even in a well-built loop, you're going to get more noise from 8 fans than 4 fans. It's common sense, right? So as long as you have enough rads, that is. So the thickness, I would say, use slim rads for the most part. They do a great job. There's no real reason to get a big thick rad. They cost more. You have to buy more fans. And your performance at best is not going to be any different. We're talking within the margins of 1 to 2 degrees. Assuming you have like a complete built out thick rad setup with multiple rads, a crap ton of fans, you're not really gaining much. The most important thing is to buy high quality components. Buy the best rads you can get. Don't buy a rad just because it's popular. Go to sites like I think Extreme Tech, stuff like that. They'll have radiator reviews, and pick your rads from there. Not all rads. For example, let's take an EK360. I would say PE. Okay, that's like 45 millimeter. That rad requires a higher fan speed, something of like 1,000, 1,100, 1,200 to work well, right? So that may not be a good fit for some cases, right? So if I'm trying to fit that into a case that doesn't have a huge gap between the panel and where I mount the rad, and a lot of cases are like that these days with the glass, then that's going to make a lot of noise and not work so well. So something like a 360 GTS, those work best at around 800 RPM, right? That would be a better radiator for that scenario. So you have to consider these things, not just buy what's popular and buy what you think looks best, because it's a balance of getting the best radiator for your usage. And with that, it pretty much wraps it up. I think this video is helpful even for a lot of people who've been water cooling for a couple of years. Just because you've been doing something for a while doesn't mean you've been doing it correctly, right? So, and this answers a lot of the questions I see online. I think it's a shame that the bigger tech tubers don't cover this kind of stuff, even though they talk about water cooling. Yet I see most of them doing it wrong most of the time. And I guess one more thing is PETG versus acrylic, right? So people always go, oh well, when you look online, they go, oh, one shatters easier and that's it. No, there's more differences than that. PETG has a blue hue, even though it looks clear. So acrylic does look more clear. And if you're running pastel fluids, acrylic will always look better with pastel fluids. And some coolants, some Mayhem's coolants, like you cannot use PETG with. That's anything with. Yeah, I don't want to list all the coolants off the top of my head. It's quite a bit. Anything with glycol pretty much is not PETG friendly. So acrylic at the same time, it's a little harder to work with. You have to be more accurate because you have to get a saw. You can't just cut it with a pipe cutter like you could with PETG. But the bends come out cleaner. It does take a little longer to bend. It takes more heating up and more even heating. But another thing is it doesn't deform. Right? PETG starts to deform at 50 degrees, somewhere around there, 50 C. So let's say your pump died and your water temp got really, really hot. and your PC didn't shut off, your PTG can actually deform, fall out of shape, and cause a leak, right? That's another reason to use acrylic. So just a bonus thing I had at the end, and hope you found this helpful. And if you know anyone that has a bunch of water cooling questions, just show them this video.